talking about a myth in this context. Sometimes we're talking about myths in the form of Greek tales or Norse tales where we have gods and goddesses and so forth. But in this case, we're talking about an unfounded or false notion. And when we're talking about scientific myths, we're talking about a myth, a belief that is thought to be scientific, but is not. And those can take two different forms. One is, in some cases, science has actually proved those myths to be completely bogus. Just flat out, no, this is wrong. This is not a phenomenon. And in other cases, it's not necessarily false. It's just that science has not been able to demonstrate it yet. The jury's still out. In fact, the research may be ongoing to see if they can prove that. So some of the things I'll be talking to you about today will fall in this category. Some of the others will fall up here. But it allows you to be a little bit more of an educated consumer when we start talking about some products that are sold, peddled, whatever word you want to use, as brain enhancement products. So probably one of the biggest myths out there is the idea that we only use 10% of our brains. This has been repeated in pop culture for over a century. I think there was a movie a few years ago with Scarlett Johansson where she somehow was able to tap the rest of her brain and it gave her all kinds of superpowers. And the rest of us just have this tiny, lowly little bit of brain matter that actually functions, and the rest is just wasted space. That is not true in the least. Why would we have all that sitting idle? It just makes no sense. From an evolutionary perspective, it makes no sense. So there have been a number of experiments over the years using different types of brain scanning technology, including something called fMRI, which is functional magnetic resonance imaging. And it's been around for about 30 years now, I think, but it really revolutionized brain imaging and brain research. And it showed that much of the brain is engaged in the simplest of tasks. Also, if you get an injury to a small bit of your brain, it can have profound consequences all over the place in there, with your language, with your sensory perception, with your movement, even your emotions. So let's say, for example, that you're watching this slide right now, which hopefully you are, and listening to me, hopefully you are, but you're also eating a piece of candy. As you're doing that, the frontal lobes in your cerebral cortex are engaged in thinking and reasoning as you're absorbing all this information in. You're enjoying your candy thanks to your parietal lobes. I know these are a lot of technical brain terms, but I'm just kind of giving you a lay of the land on the different parts of the brain coming into action. But the parietal lobes are responsible for taste and texture and the smell of food. The occipital lobes help you process how you see the words on the screen. They do some visual processing for you. And the temporal lobes help you process what you're hearing. And meanwhile, your cerebellum is helping you keep balanced and coordinated, even if you're sitting down. And you also have your breathing, circulating, even if you're eating right now. You're doing that without thinking about it, thanks to your brainstem. So all of these things are going on at once, and that's far more than 10% of your brain. So you also hopefully will employ your hippocampus to remember what you learned today in this class. The role of the hippocampus is to transfer short-term memory to long-term memory. And hopefully that will also enable you to remember that the point of this long-winded example is to tell you that you use much more than 10% of your brain. And here's the other big one. And I hear people still use this term a lot. I'm left brain or I'm right brained. And the idea is that left brain people are more technically minded, they're more analytical, methodical, and right brain people are more creative, more artistic. But in fact, the two sides of the brain are very codependent. They work really with each other. And brain scanning technology, again, has shown that the two hemispheres of the brain really work together in complex processing. So language processing, for example, that was once believed to be the provenance of the left hemisphere of the brain. Only now it's understood to take place in both hemispheres. So the right side of our brain processes grammar and pronunciation, and the right side of the brain processes intonation, some of the more nuanced aspects of language. And what remains true, though, is that, yes, the right side of your brain controls the left side of your body and vice versa. And that you may have heard before, too. And that is true. And that means that if you get an injury to the left side of your brain, say from a stroke or something like that, that can cause damage to the other side of your body. You might have some paralysis on the right side. So don't feel that if you are not necessarily great at math, like I'm not great at math, but I don't go around telling everybody I'm a right-brained person. Both sides of my brain are working. Okay, this one I want to show everybody, and this is just an image of a lung that would be something that a radiologist would look at. I want everybody to look at it and just let me know what they see, if they notice anything in particular, anything interesting, maybe something that might signal to you that something's wrong with this lung.